Okay, this is a quick start guide for the Megawatts and Marbles helper program. It's a little program I put together to help with facilitating localized play sessions of Megawatts and Marbles. And by that I mean if you're going to be hosting a Megawatts and Marbles game in a particular location and you'd like to use electrical load data for that location as well as solar and wind resource data for that location, this is a little program that helps you do that. So it's open source and it's on GitLab. You can see the URL here. I'll put the URL in the video description so you can get to it more easily. And we can grab this code very easily. So if we just click on code and we click on zip, it'll download. I've already downloaded it once before, so I'll get rid of the old one. And I'll just extract this to my desktop. And that's it. Got the files. All right, now that we've got the files, we need to get set up in order to use this little program. So it comes with a README that we can refer to. And for this video, I'll focus on Windows users because that's probably the vast majority of you. And if we scroll down, this is what we want. So we got setup and quick start. So first of all, there'll be a video. So I'm gonna the URL for this video once it's ready is what's gonna go here. So I'll update the README once it's finished. Before we try and run this build test document script, which is a script I provided to automate all of the install and testing and documentation, we need to get an API token for what's called Renewables Ninja. So if we go to Renewables Ninja, the URL is actually up here. I'll add that down here in the next version. But if we go to this URL here, we can register for an account on Renewables Ninja. And then once you register for your account, you should be able to go into your account profile and get an API token. It's like a big string of letters and numbers. Renewables Ninja is pretty cool. Basically what this does is pick any point on Earth and you can get data for solar resource and for wind resource, as well as heating and cooling demands and weather. So for the Megawatts and Marbles helper program, we just make use of solar and wind. So it's important to be set up with a token, an API token, in order to go and pull that data. And it's all free. You sign up, you get a token, and you're good to go. So once that is done and you have your token, you're going to want to look at there's a little JSON file, so JavaScript object notation. You should be able to open it in the editor of your choice. I'm using Notepad++, and it'll be a simple little plain text file here. So whatever your API token is, just copy and paste it into here and save the file. And that should be good enough for that. Actually, just so you understand what I mean about getting your API token, we're back in Renewables Ninja here. I'm logged in now, so you can see my little user profile button over here. So if I click on this, just left click, there's this profile option. If you click on that, it'll bring you to a page that shows your API token. Again, it's just a long string of letters and numbers. So that's what you're going to want to copy and paste into that token JSON file. Okay, so now that we have taken care of that token.json, so our renewables.ninja API token, we're gonna want to run this build test document script in order to get set up. But assuming you've never used Python before, you're going to need to install a Python interpreter first. For mmhelper to work, we're going to want to use Python 3.12 specifically. So we'll just have to grab the installer for the right version of Python. So if we look here, there's a URL we can go to download the installer. So we're going to want to scroll down to specific releases. The latest 3.12 that has an installer is 3.12.10. So we're going to want to click on 3.12.10. And we're going to want to grab one of these Windows installer files. that should do it for us. I'm using this one for this particular machine. I've already downloaded it, so I'll just go to my downloads and make use of it. So that's this guy. All right, so just run him. You're going to want to use admin privileges, and you're going to want to add Python to the path so that you can find it from your command prompt. Just go ahead and install it. Doesn't take very long. All right, and that's it. If you do see an option pop up for disable path length limit or something to that effect, you're going to want to go ahead and select that. So we'll close this down. And if we go back to any folder, really, like I can even just do it from downloads. Just click in the address bar here in the file browser, type cmd. That opens up a command prompt in the downloads folder. Because we've added Python to the path, I can just invoke the interpreter from anywhere, and to get the version we can do -version, and it should return 3.12.10 because that's what we just installed. So we see 3.12.10. If you get something like Python not recognized or not found or something that isn't this, then the install didn't work. So that's it. That's getting set up with Python. And for users of Windows, there is still one more dependency that we need to worry about. So the Megawatts Marbles helper makes use of this time zone finder package. Basically what that does is that maps latitude and longitude to the appropriate time zone. And that's used for data you download from Renewables Ninjas and UTC, but we want to be able to express that in local time in order to line it up with load data. So we need to be able to make use of this package. But on Windows, that means we need to have the this C++ build tools installed. And we can do that through Visual Studio. So there's another URL here that we can navigate to. And you're going to want to click on this Download Build Tools button. That essentially just downloads the Visual Studio installer, which I've also already done. So I'll show you what you need to do with that. So if we go to this Build Tools and just run it. All right, awesome. Visual Studio. All right, so I've already done a bunch of stuff, so I'll just hit modify. I've already installed this because it takes a little while. It has to download a bunch of stuff. It's this desktop development with C++ workload that you're looking for. So you want to tick that box. The default selections here are fine, and then just hit this install while downloading button, and it'll pull like 5 gigabytes or something silly down, but that's what you got to do on Windows to make this work. Okay, so now that we have finally jumped through all the hoops that we need to jump through to get this thing to work on Windows, we should now be able to just run this build test document script. So how do we do that? Well, we just run it using the interpreter. If you're on Windows, you just write Python. If you're on Linux, you probably have to write Python 3, unless you've aliased it or something. But well, this is for Windows, so we'll just run Python. So to do that, we need to, and actually if we look here, it tells us it's in the Python directory. So we need to open a command prompt in that directory. So let's open up our project here, go into Python. All right, awesome. So now we need to open up a command prompt here. And if we want to verify that our build test document script is visible, we can just directory, and there it is right there. Right. CLS to clear the screen. Invoke the interpreter. Type the first couple characters of our script name and just hit tab. And we should be able to run this now. So what's going to happen is it's going to install all of the dependencies that we need to run mmhelper. And then it's going to run a test suite. So when the test suite is running, a bunch of plots will pop up. That's normal. Just close them until testing finishes. And then it'll carry on with documenting and style guide compliance and cleaning up and a bunch of other stuff that's aimed more towards developers. But this will get you set up so that you have everything you need to actually run it. So let's go ahead and run this. It's going to install all the dependencies. All right, so that's all done. If you're doing it for the first time, it'll probably take a bit longer. Now we just hit enter to test to go with the testing. So now to run the test. So a bunch of plots pop up. So this is just electrical load data. So there's a time series, and then there's the corresponding monthly violin plots. They're kind of like box plots, but there's more information there, so I kind of like them better. And then it'll show, this is resource data, so there's the monthly violins for wind, and there's a year's worth of wind time series. Solar violins, monthly, and solar time series. And now we're actually playing the game. So this is the first, that's the demand in the first step. That's the solar production, that's the wind production for just a test case. And this is basically how it works. Every time you close these plots down, it generates the next stage of the game. So these are, basically it's like drawing play cards. So I'll just close these down. This part is a little bit tedious, but it works. Get rid of these. Obviously this would go much slower if you're actually playing the game, so it shouldn't be too bad in practice. Just in testing it can be a little annoying. Alright, let's get rid of all these. I won't make you sit through all this. Alright, so that testing is all finished. So now we proceed with PEP 8. So that's just Python style guide compliance. Just makes use of auto PEP 8 to make sure everything is clean. Proceed with documenting. I'm using pdoc. I should probably figure out Sphinx at some point, but for now, pdoc is what I know. And then clean up. Just clean everything up. All right, so if that all worked like that on your end, then you're set up and ready to go. All right, we made it. We're finally set up and ready to go. Okay, so this run script, this is what we actually use to run the helper program. So we need to be in that directory. All right, so now we're in the main. We're in the main here. So if I list contents, there's my run script. That's what I need. All right, so if I run this run script, so invoke the interpreter, pass the script name, tab to autocomplete after you type a couple of characters, and then just hit enter. Awesome. Here we are. Again, this tutorial link, I'll put it here. I'll put it here when it's ready. All right, Megawatts Marbles helper. Here we go. Okay, so once you hit enter, it'll bring up a pop-up window, and it'll ask you to select where your API token JSON is. So it's provided here, but really you can store it anywhere you want. So we'll just select this file, use this. All right, cool. Now we need to choose our solar resource latitude. So this is where we make use of the Renewables Ninja API to go and grab data for us. This already ships with some data. So we've got our solar resource data here. So this data that's sitting in the data folder, that might have been a bit fast, let me back up. All right, so here's the root directory for our mmhelper program. If I go into data, and I go into solar resource, this is like a local database of solar resource data. So we can see here we have data for latitude 54 point bunch of numbers degrees, longitude -132 point bunch of numbers degrees from this date to that date. The reason why I'm telling you this is because if you put in latitude and longitude and a year for which there isn't already data in the database, then it'll get pulled from the Renewables Ninja API. But if you pass in a lat and a long and a year for data that's already there, the program will just use the data that's already in your database. It won't even reach out to Renewables Ninja. So to show that working, I'm just going to pick a different latitude and longitude. So let's say 50 degrees north, 125 degrees west. Let's say that. And then I'll do the same for wind. So if I go into wind, I'll give it the same. So let's say 50 degrees north, 125 degrees west. All right, now it's asking me to select my demand or electrical load time series data. So if I go into data, there's one example that ships with. There's demand, and there's this guy here. So if I select this, it'll read in that demand data. And if you want, well, actually, that's the intent. This can be used as a template. So if we open this up, in Excel or whatever spreadsheet program you want. This is the kind of the format it's looking for. So you need to express your date times in ISO 8601 format. If you don't know what that means, you can look it up, but essentially it's year, month, day, and then a time string in 24-hour format. And then in this column we have the demand in kilowatts. This data is in 15-minute time steps. That doesn't really matter. As long as you give it at least hourly resolution, that's good enough for mmhelper. I just happened to have this data in 15 minutes, so I left it in 15 minutes. And you do need a full calendar year, so from January 1st midnight all the way through to December 31st at the time step before New Year's. So you do need a full year of data. So as long as you follow this format, you can put whatever numbers you want in here, and just remix and reuse this file to your own ends. No, I don't need to save that. All right, awesome. So we've already done all that. So I'll go into solar resource again just so we can see. And now we need to enter the year for the resource data. You should really pick the same year as the demand data to make sure everything lines up realistically. Our demand data here is for 2023, so I'm just going to put in 2023. Awesome. Cool. All right, so there's our minimum demand, our maximum demand, and then there's this conversion factor. So this is part of the localization. So for this particular demand time series, a megawatt is about 5 1/3 marbles. Is the way it all lines up here. And you can see that this new data file has appeared because it wasn't already in the database. So mmhelper fetched it from Renewables Ninja. We can see the same for the wind resource. There it is. Okay, so that bit's working. All right, next we need to choose an installed solar capacity. But before we do that, if we look at this figures folder, you see that a bunch of figures have been generated. So for example, this is, I don't care, just open it. Awesome. All right, cool. So this is a time series of the electrical load. So there we see the full time series. And we can see how the localization has worked in this case. So the peak load of 5.6 megawatts is being mapped to 30 marbles. And this is a default setting for mmhelper. If you want this 30 marbles to be something else, you can look at the documentation that ships with this program, and you can change it in the localizer class definition. And the baseline here is 1.36 megawatts, which works out to 7 marbles. And you can also see the same in violin plot format. So for any given calendar month, this line here, for example, in January, this line here is the mean, this is the minimum, this is the maximum for that month, and then you can see how the loads are distributed about those extrema and where the mean is. So this is kind of like a probability density turned on its side, or like you think of it as like a histogram. So where the violin is widest is most probable, where the violin is thinnest is least probable, roughly. All right, so there's demand information here, but we also have resource information. So if I just open the violin plots, so I'll just open that one's solar, that one is wind. Yeah, so that one's solar, that one's wind. So there's our solar resource. There's our wind resource. So we can look at these resources and sort of compare them to the load. And then this will help us strategize. Okay, what kind of technology mix do we think might work well for this play session? And oh, by the way, you'll be playing a random day of the year, so you don't know exactly which day of the year you'll be playing, but you do have visibility of all this data, so you can use that to plan out your system mixture. Okay, so these figures are generated. These figures will already be generated in this folder and ready to go by the time you get to this point in the play session. So given that, let's see here. So what are we peaking? We're peaking at a little less than 6. All right, so why don't I just use that to size my component? So let's say we install 6 megawatts of solar, and let's install 6 megawatts of wind as well. Why not? Right, so I'll just set both of those equal to pretty much the peak. And we'll see how well that works. All right, cool. So once we've sized our solar and our wind, then we get to know what date we're playing. So it looks like we're playing April 15th, if I'm right. Yeah, April 15th. All right, so that means that we are in this violin, right? So the average load is around 3.5 megawatts. So however many marbles that translates into. How do our resources look for April? For April, solar is okay. Well, I mean, actually, it's down here like, I don't know, 11% capacity factor, so I'll take what I can get. What does wind look like in April? About the same. Okay, well, our solar and our wind may not do a whole lot for us, but that's just for that month. So maybe it's a good day for those. We don't know, but we'll see when we play through. All right, so ready to start playing now. So once I hit enter, a bunch of plots come up. All right. So one of these plots, so this is our wind production, which in the midnight to 2 a.m. step in this case is, we can see here it's 11 marbles. So that's the localization, so 11 marbles. And how that translates in this case is that's 2.1 megawatts of production from wind, which is a capacity factor of 0.35. So a 35% capacity factor given that we installed, what, 6 megawatts of wind? Yeah, right? So that's how many marbles the wind is spitting out in this time step. Solar, not surprisingly, is 0. It's the midnight to 2 a.m. time step, so there's no sun. And this one here is our demand. So our demand right now is 17 marbles, or 3.2 megawatts in this case. All right. So at this point, the players would be staging their marbles at their different production assets and figuring out how they want to play this round. And then once that decision has been made, you simply close all these plots, and it'll advance you to the next game step. Bingo. Right, so it's like these cards are being procedurally generated for you. And then once you're done with them, you just throw them out and you'll get the next set of cards. So there's our wind production. Solar is not doing anything, so I'll just get rid of this now. All right, so here we go. So the plot on the right is our wind production in the first 2 time steps, and the left plot is our demand in the first 2, well, game steps, I should say. So right now we're in the 2 a.m. to 4 a.m. step. We got 16 marbles of demand, so 3.1 megawatt, and our wind is again producing 11 marbles, so 2 megawatt or a 34% capacity factor for this time step. So it's not doing too bad. It's covering a fair bit of the load, but we'll need to make up the difference with something. All right, and then I will just I'll click through the rest of these cards because it's, you know, look at the cards, play the step, throw out the cards, get the next set of cards. So I'll just skip to the last time step. All right, so we're in the last time step now. So you can see what wind did throughout the course of the play day. Right, so again, April 15th. This is what wind did for us that day. This is what solar did for us that day. So we got a little bit of solar around the middle of the day, but not a whole lot. The capacity factor was kind of lousy today. So wind actually did really well. There was capacity factors of like, what, 40%? I clicked it away too fast, but it was up there. So wind did fairly well. And there's our load. So yeah, not too exciting. There's a little bit of a dip and a ramp up in the morning, and then it was pretty flat for the rest of the day after that. So as soon as I close this last one, we're done. It just says thanks for playing. We've completed a play session, and that took however long it took. Now if we go into our figures folder, there's the cards. So if we want to go back and look at or discuss what happened, we can always open these back up. Yeah, we can go over them. So that's all been recorded for you. And that's pretty much it. So yeah, it's a simple little program that helps localize megawatts and marbles to a solar and wind resource location together with a user-defined electrical load time series. Pretty simple. So hopefully that's of use to people facilitating megawatts and marbles.